My name is Jan, and I am in charge of the Scilab business unit in ESI Group. For this first presentation, I want to welcome everyone to the Scilab community. For that, I would like to go through a brief history of Scilab. It is a story about software and science, but above all, it is a story about men and women. This introduction in the beginning is about thanking everyone who made this event possible. I want to start by thanking ESI Group for organizing this Scilab conference, in particular Laura and Gaël and Aurélie, present here today with us. Good morning, Laura. And I also want to thank Mozilla Foundation, in particular Sylvestre, who used to be part of the Scilab team. And thank you for inviting us in this wonderful location in the center of Paris. Finally, I want to thank all of you for being here, especially the speakers. Here, as you can see, we have a very full agenda today, and so I'm delighted to have you all here today. Let us shortly go back in time. What you see on this picture, it is the last community event we had in France in the very same room. It was in 2015. So, this is a short summary of previous episodes. It was a very successful event. The three best presentations of the event were based out of the votes of the audience. In the first place, the French Nuclear Agency, CEA, presenting on their migration from MATLAB to Scilab. Second was from our Italian partner, Evidence, on state machines with Scilab and Excos. And the third one, from the French Space Agency, we have them today again. So Alain and Thierry, you will be presenting further some space missions. Today it's Mars. Last time it was about landing on a comet. It was a very successful event, and we had every year before this one, user conference called Scilab Tech since 2009. They were organized very professionally by Julie, who was in charge of the communications in the days at INRIA, the French research. But I'm not going to lie to you, the last 3 years have been quite challenging. Even though Scilab goes back long time. Its origins are coming from the 80s and the 90s. And its expansion goes far beyond our small team. So here is a short timeline of the three main steps, I would say, of our history up until today. Now I want to go through this short history of time with you. First, Scilab started formally in 1994, and its premises are going back to the expertise of INRIA. INRIA is a French research institute for computer science. In this research center, in the Paris area, we had a team of giants, as you can see in this list, who paved the way for a large scientific project. I was lucky enough to meet two of those giants, Serge, who some of you might know, he was presenting at the last Scilab conference, and Claude, who operated the transition from INRIA to Scilab Enterprises. In 2003, there was the first Scilab Consortium, whose goal was to drive the roadmap of the software. Those are the founding members from the French elite. And since 2008, our goal was to industrialize the development of Scilab, to conduct a transition from the research to a large industrial adoption. A new generation of computer scientists took over the development of Scilab. Today we have some of them, Clément and Antoine. Antoine, who's the architect of Scilab and our oldest team member, will be joining us. He's been around for 10 years now. So thanks to those talented software engineers, we were able to make a solid and robust software. I'd like to remind you that 2008 was also the first version of Scilab 5. Today we are at Scilab 6. So as the industry was starting to adopt Scilab, there was a rising need for services around the open source software. And it was the very reason for the creation of Scilab Enterprises. The whole development team switched over from INRIA to Scilab Enterprises in 2012. And we soon figured out that from the expert usage to the development of application, our main competitor was actually not MATLAB, but it was rather Excel. So we figured out that lots of our main users were packaging together data with algorithm and developing on top a graphical user interface in order to develop what we call application. This is also what led us to Scilab Cloud, to a new technology and an underlying business model for the deployment of application. It was in 2016. And today you will see a presentation from Sanofi, from Jean-Pierre, about the very first industrial use of Scilab Cloud for in energy consumption in the pharmaceutical industry. But around those time, we also had very important research projects which were enabling to develop Scilab further. I'll quote just some of them. Colloq was led by Cedric in our team, and it was to stay close to our friend in HPC, high performance computing. Another very important and major project for Scilab Enterprise and for Excos was Argo, and it was brilliantly orchestrated by Clément. Today you will see two presentations, one from the German Aerospace Center on control system for flight simulator, and just after my presentation, one from the Fraunhofer Institute, the very same Fraunhofer Institute who invented the MP3 technology next to Nuremberg. And today they will be presenting you image processing. There's even a demo in backstage. One last research project that I wanted to quote is Megasif. It was a very first taste for us of what is finite element analysis and the development of reduced order modeling. It was a foundation for our future as we got closer at this time already to ESI Group. And from that time on, we also saw a new generation of promising engineers, Hughes, who's with us today, who has a strong expertise in the domain. So if you have questions, don't hesitate to ask him. And you will see also a presentation from one of our partners, Bertin, later today, from Sophie. So it ends up with the question, why ESI at the end or the beginning of this journey? Why did we join ESI? So to give you some perspective about the simulation and analysis market, it's a $6 billion market, and it's quite strongly concentrated. As you can see, there's just a few players that are taking it all, basically. ANSYS is number one, and closely behind, you can see that MassWork is also leading with close to no competition at all, almost. But in both cases, there's a very strong academic footprint, and it creates a natural barrier of entry, unless we have a value proposition that is highly disruptive around open source and that can challenge this status quo. So who's ESI? In a few slides, I'll try to introduce you to this pure player of the simulation market. What is smart visual prototyping? The differentiative proposition of ESI is to go from analysis, simulation of simple physics, thermodynamic, structural analysis, and so on, until virtual testing, taking into account the manufacturing effects. And this is what produces a virtual prototype. Now, the next step now for the future of ESI, and it's also the reason why ESI acquired Scilab, is to go to smart virtual prototyping, meaning that it's not good enough to have an analysis of the product conception, the design phase and engineering, but it's very important to see this product in operation, in service, and to assess its performances all along the product life cycle. So this is a short overview of all of the technologies that ESI is developing around 3 pillars: engineering, manufacturing, and in-service. And early on, since 2012, ESI already showed an interest for open source through the acquisition of the OpenCFD team developing the OpenFOAM software for CFD, for computational fluid dynamics. So this acquisition goes along with this strategy of building technologies and not only product, but also services around solutions. As a summary, today ESI is it's not that big of a company actually. It's around 1,200 people worldwide, but it's fairly largely spread all around the world. And it leads me to the last part of my presentation on Scilab all over the world. So I started to work for Scilab about 5 years ago, and in the first place I was supposed to develop the business in Germany. We organized, with the help of Jürgen Koch, a professor in the area of Stuttgart, a Scilab conference at that time, and some of the people that were presenting will be here today also. You will have a presentation from Hochschule Esslingen today. We have very large activities at the moment in Japan. As you can see on this picture, there's already a strong competition happening. And well, we had a first meetup with a small group, a small representation of the community last year already, and I actually just wrote this presentation on the plane back from Japan. So India is also a very large user of Scilab. Just simply in the academia, I want to thank Kanan Mugdalia from the IIT Bombay, who has been spreading the use of Scilab. Thanks to him, you can see on this chart, there's around 240,000 students that were trained with Scilab. It is actually more than Python in engineering school. So here, this is the spread over the years. And this year, in August, we had a conference in India, and this is Professor Kanan Mugdalia presenting around the open source supported by ESI on OpenFOAM and Scilab. And obviously, friends, we won't forget our roots. There's a very large community, also lots of academics. Every year, there's around 30,000 students from preparatory classes, from engineering school, from the university that are learning Scilab. It produces sometimes some funny results. When I have a look at the social networks, sometimes I stumbled upon such funny tweets. So this is also the new generation speaking, I guess. And in the US, well, the US is it's a bit difficult, to be honest. I would say it's MATLAB land. But something funny happened. It was in the beginning of 2017, as we were joining ESI, and we saw this post. So we decided to contact John, and yeah, I'll tell you a bit about John. So John Eaton is the member of the Resistance, I would say. It's the founder of Octave. And those are a few slides from him on Octave. So why the name Octave in the first place? It was a reference to a professor who passed away last year. And those are a few, in a few lines, the origin and the history. Actually, Octave started out as some sort of a textbook companion on chemistry, because John at that time was studying chemistry. Well, the first release, 1994, might sound familiar to you, it's the same year as Scilab. In 2002, the book that was supposed to go along the software finally was published, but well, the software was already growing and in a direction that surprised John in the first place, because it did not intend to make a clone of MATLAB at the first place. And so, if you look at it, this is the scope of the project. So this is actually a photo from John. He highlighted all of the functions that he found in the first manual of MATLAB, and he was just trying to, implement all of them. And he saw that at that time, well, it cannot be that hard, Look at it. Well, now it's a bit more challenging, I would say. So it made us also meet new people. And here today we have Botao, who will be presenting, coming from the US. So thank you very much for coming all the way, on the use of open source in an enterprise computing environment. But let's go back to Scilab and the usage throughout the community. I have a few slides, 3 slides on some statistics here. This might interest you, just to have a look at the different application field where Scilab is being used. Those data are coming from form. When you download Scilab, you can fill up a form. You don't have to, but you can. And here we have a sample of around 100,000 downloads that filled out this form. So in the first place, there's a lot of users using it in electronics. Second is data analytics. And mechanics is coming in number 3. Now, in terms of domain, including the education, as you can see, education is very strong. So 63% of our users come from the education, and the rest is industry. And those are the different industrial domain where Scilab is being used. So research is in yellow. It's very strong also. And afterwards you have a lot of different fields. So I'd like to conclude this talk to now talk a bit about the future of Scilab. And here I'm actually adding a graph that is coming from a feedback of a teacher. He has been using Scilab for 15 years. His name is Klaus. And those are the kind of things that give me motivation to keep investing efforts in Scilab, to see so much things produced by the community. Now you might wonder, where are we going? And this is also the purpose of the final talk of today. But here in one slide, I'll try to sum up our strategic targets for the future in terms of who are we going to aim at. In the first place, obviously, we will want to bring additional value to existing traditional simulation user. Here, making a competition to ANSYS and not MATLAB directly, but trying to bring in different domains such as CFD, so computational fluid dynamic, some model reduction technique, in vibroacoustic, bring some optimization. Those are some of the projects that we've been doing in the past 2 years, and some system model deployment. The second target is obviously system simulation engineers, so in competition with MATLAB. And here our value proposition is to embrace open source, to unlock the engineering productivity that goes along with it. So if you have additional resources that will join your team, well, you'd better off using an open source software that can scale with your engineering needs. And obviously, in the automotive domain, model-based design is big. In the signal processing, also for chip design, as you will see later today, there's a strong need for that. So in both domains, whether it's control system and block-based diagram or scripting, this is something where we want to grow bigger. And the last part that we don't want to forget is about application developers and to provide them as a, well, I said competition to Python, but really is there a competition when we're talking about open source? It's mainly to bring and discover the potential of simulation, what goes around mathematics, optimization, statistics, signal processing, and control system, to bring all of those value to fields that are new to the simulation, mostly. So if you look at some of the presentations that we will have, for instance, from Sanofi in the pharmaceutical, this is a field that is not as mature as aerospace and automotive. And we also have lots of examples in process industries, for instance, in risk modeling. So those are domains where there's a very large potential to enlarge the use of Scilab. Thank you.